Every night, thousands of objects silently orbit our planet. Weather satellites, communication relays, space stations, debris from decades of human space exploration. But according to some researchers, there's something else up there. Something that's been watching us for far longer than we've been watching the stars. They call it the Black Knight satellite. And if the stories are true, it's been circling Earth for over 13,000 years. Before we dig in and explore this incredible mystery, I'd just like to know how your night is going and where you are listening from. And I'd also like to thank you for stopping by and welcome you to ConspiraNap. And if you're a regular, welcome back. Please take a quick moment to subscribe, as these videos take quite some time to create, and I'd love to share it with others who are interested in this and similar topics. Now, before you click away thinking this is just another alien conspiracy theory, let me tell you something. The evidence for this mysterious object spans more than a century. We're talking about documented radio signals that baffled Nikola Tesla himself, photographs taken by NASA astronauts, and observations by respected scientists that still don't have satisfactory explanations. I'm talking about a story that weaves together early radio experiments, Cold War satellite detection, and a modern space photography into one of the most persistent mysteries in UFO research. A story that's been dismissed by mainstream science, embraced by conspiracy theorists, and ignored by almost everyone else. But here's what's really interesting. The more you dig into the official explanations, the more questions start emerging. Why did Tesla think he was receiving signals from another planet? What were those mysterious objects detected by the US Navy in 1960? And why do those NASA photographs from 1998 show something that looks nothing like any known piece of space debris? I've spent weeks researching this, going through declassified documents, NASA archives, and scientific papers. What I found is a mystery that's far more complex than either the believers or the skeptics want you to think. Because while there are perfectly reasonable explanations for individual pieces of evidence, the complete picture tells a story that's genuinely puzzling. So let's start at the beginning. Let's go back to 1899 to a laboratory in Colorado Springs, where one of history's greatest inventors was about to detect something that would haunt him for the rest of his life. Nikola Tesla was no ordinary scientist. This was the man who gave us alternating current, the induction motor, and wireless technology, decades before anyone else even understood what he was talking about. In 1899, he was working alone in his specially built laboratory in Colorado Springs, conducting experiments that pushed the boundaries of electrical science. The lab itself was like something out of science fiction. Tesla had constructed what he called a magnifying transmitter, a massive coil system capable of generating millions of volts of electricity. He was investigating wireless power transmission, atmospheric electricity, and the fundamental properties of electromagnetic waves. His equipment was so sensitive, it could detect electrical disturbances from lightning storms hundreds of miles away. But on one particular night in July 1899, Tesla detected something else entirely. He was monitoring his receivers when he began picking up strange rhythmic signals, not the random crackling of atmospheric interference or the chaotic patterns of lightning strikes. These signals had structure. They were organized. They repeated in sequences that Tesla described as counting codes: 1, 2, 3, 1, 2, 3. Over and over again. Tesla was convinced he had made one of the most important discoveries in human history. After ruling out every terrestrial source he could think of, he came to a startling conclusion. These signals were coming from another planet. Possibly Mars, possibly Venus, but definitely not Earth. He wrote about this experience years later, saying, "The feeling is constantly growing on me that I had been the first to hear the greeting of one planet to another." Tesla genuinely believed he had detected the first evidence of extraterrestrial intelligence. Now, here's where the story gets interesting. Modern scientists have offered several explanations for what Tesla might have detected, Some suggest he was picking up signals from Jupiter's moon Io as it passed through the planet's magnetic field. Others point to pulsars, those rapidly rotating neutron stars that emit regular radio pulses, though pulsars weren't discovered until 1968, nearly 70 years after Tesla's experiments. But here's the problem with both explanations. Tesla's equipment in 1899 wasn't sophisticated enough to detect signals from Jupiter, and it definitely couldn't pick up pulsar emissions. The frequencies were wrong, the power levels were wrong, the whole technical setup was wrong for detecting either of these phenomena. So what did Tesla actually detect? The honest answer is nobody knows for certain. What we do know is that Tesla was using some of the most sensitive radio equipment ever built up to that point. He was an incredibly meticulous scientist, and he detected structured, repeating signals that he couldn't explain using any known terrestrial source. And according to Black Knight satellite theorists, those signals were coming from an ancient alien probe that had been orbiting Earth for thousands of years, occasionally transmitting back to whoever sent it. Tesla's mysterious signals would remain unexplained for decades. But 28 years later, halfway around the world, another radio operator would detect something equally puzzling. In 1927, a Norwegian civil engineer named Jørgen Hals was experimenting with radio equipment from his home near Oslo. Hals was what we'd call a ham radio operator today, someone who built and operated radio equipment as a hobby. But unlike most hobbyists, Hals was about to stumble across a phenomenon that would baffle scientists for nearly a century. Hals was listening to transmissions from a Dutch radio station called PCJJ in Eindhoven when he noticed something strange. Along with the normal signal, he was receiving echoes. Not just the typical echo that bounces around Earth and returns after about 1/7 of a second. He was hearing a second echo, much weaker, that arrived several seconds after the original transmission. This shouldn't have been possible. Radio waves travel at the speed of light. Even if they bounced off the moon and back to Earth, the longest possible delay would be about 2.7 seconds. But Hals was detecting echoes with delays of 3, 5, even 15 seconds. When Hals reported his observations to Professor Carl Sturmer at the University of Oslo, Sturmer was skeptical, but he was also intrigued enough to investigate. Sturmer teamed up with a Dutch researcher named Balthazar van der Pol, and together they began conducting systematic experiments to verify Hals's claims. In October 1928, they transmitted radio signals at regular intervals and monitored for delayed echoes. What they found was astounding. Van der Pol sent a telegram confirming the results. Last night, special emission gave echoes here, varying between 3 and 15 seconds. 50% of echoes heard after 8 seconds. These long-delayed echoes, or LDEs, represented a genuine scientific mystery. If radio waves were bouncing off something and returning to Earth with delays of up to 15 seconds, that something had to be much farther away than the moon. The calculations suggested the reflecting object was somewhere between 50,000 and 200,000 miles from Earth. But what could it be? There were no known natural objects in that region of space that could reflect radio signals. The closest planets were millions of miles away. And this was 1928, 30 years before the first artificial satellite would be launched. LDEs continued to be detected sporadically over the following decades. Radio operators around the world reported similar phenomena, always with the same characteristics. Weak echoes arriving several seconds after the original transmission, with no apparent pattern or source. The scientific community proposed various explanations. Maybe the signals were bouncing off ionized gas clouds in space. Maybe they were reflecting off meteor trails. Maybe there were atmospheric conditions that could trap and delay radio waves. But none of these explanations fully accounted for all the observed characteristics of LDEs. And then, in the 1950s, the mystery took on a new dimension when UFO researchers began paying attention. The 1950s were the golden age of UFO sightings in America. Flying saucers were front-page news. The Air Force was investigating unexplained aerial phenomena, and the public was fascinated by the possibility of visitors from other worlds. Into this environment stepped a former Marine Corps major named Donald Keyhoe. Keyhoe had become one of the most prominent UFO researchers in the country, writing books and articles that accused the government of covering up evidence of extraterrestrial visitation. He was charismatic, articulate, and absolutely convinced that flying saucers were real. In 1954, Keyhoe made a startling announcement. According to sources in the US Air Force, he claimed 2 artificial satellites had been detected in orbit around Earth. This was remarkable news because in 1954, no country on Earth had the technology to launch a satellite. The Soviet Union wouldn't launch Sputnik until 1957, and the American space program was still in its infancy. Keyhoe's announcement generated headlines around the world. If artificial satellites were orbiting Earth and they weren't built by any human government, then who had put them there? Now, skeptics have pointed out that Keyhoe was promoting a UFO book at the time, and his announcement conveniently generated publicity for his work. The news stories about the mysterious satellites were often written with a tongue-in-cheek tone, suggesting that reporters weren't taking the claims entirely seriously. But here's what's interesting. Keyhoe wasn't some random crackpot making wild claims. He was a former military officer with connections throughout the defense establishment. His UFO research was methodical and well documented. And while he was certainly a true believer in extraterrestrial visitation, he wasn't known for fabricating evidence. So where did Keyhoe get his information about these mysterious satellites? Did he really have sources in the Air Force who had detected unknown objects in orbit? Or was this simply a publicity stunt designed to sell books? The truth is, we don't know. The Air Force denied Keyhoe's claims, but given the secrecy surrounding early military space programs, their denials don't necessarily mean much. What we do know is that Keyhoe's announcement added another layer to the growing mystery of unknown objects in space, and that mystery was about to get even more complicated. 6 years later, during the height of the Cold War, the US Navy would detect an object in orbit that shouldn't have existed. An object that was dark, mysterious, and initially thought to be a Soviet spy satellite. An object that would later be identified as something else entirely, but not before adding fuel to the growing legend of the Black Knight satellite. The year 1960 was a tense time in the Cold War. The Soviet Union had shocked the world by launching Sputnik in 1957, demonstrating their technological capabilities and giving them a significant propaganda victory. Both superpowers were now racing to develop military applications for space technology, including reconnaissance satellites that could spy on enemy territory from orbit. In this atmosphere of suspicion and technological competition, any unknown object in space was potentially a threat. So when Navy tracking stations detected a dark object in polar orbit in February 1960, military officials were immediately concerned. The object was unlike anything they had seen before. It was much larger than any known satellite, and it was in a polar orbit, passing over both the north and south poles as it circled Earth. This type of orbit was ideal for surveillance, as it would allow a satellite to observe the entire surface of the planet over time. Time magazine reported on the discovery, noting that the object was thought to be a Soviet spy satellite. Given the secretive nature of both countries' space programs, this seemed like a reasonable assumption. The Soviets had already demonstrated their ability to put objects in orbit, and they certainly had motives for wanting to spy on American military installations. But there was a problem. When American intelligence agencies tried to correlate the mystery object with known Soviet launches, they couldn't find a match. The Soviets hadn't launched anything that could account for this object. So what was it? The answer, when it finally came, was both mundane and embarrassing. The mysterious object turned out to be a piece of an American satellite, Discoverer 8, that had gone astray. The Discoverer program was actually a cover name for the classified Corona spy satellite program, which explains why its identification was initially kept secret. But here's where the story gets complicated. While the official explanation satisfied most observers, it raised new questions for others. How could a piece of an American satellite be misidentified by American tracking stations? Why was there initial confusion about its origin? And why did it take so long to provide a definitive identification? Some researchers have suggested that the Discoverer 8 explanation was itself a cover story designed to hide the true nature of the object. They point out that the description of the object, its size and orbit characteristics, don't match what would be expected from satellite debris. Others argue that the confusion was simply a result of the classified nature of early military space programs. The people tracking the object weren't necessarily the same people who knew about secret satellite launches, leading to genuine confusion about its identity. Whatever the truth, the 1960 incident became another piece of the Black Knight satellite puzzle. Here was a case of an unknown object in space that couldn't initially be explained, was thought to be of foreign origin, and was later given an official explanation that some found unsatisfying. The pattern was becoming clear. Throughout the early decades of the space age, there were repeated reports of mysterious objects in orbit, unexplained radio signals, and phenomena that seemed to suggest the presence of artificial objects that predated human space technology. But it would take until 1973 for someone to tie all these disparate threads together into a coherent theory. And that someone was a Scottish science fiction writer named Duncan Lunan, whose analysis of the long-delayed echo data would give birth to the modern Black Knight satellite legend. Duncan Lunan wasn't your typical UFO enthusiast. He was a science writer, astronomer, and researcher who approached the mystery of long-delayed echoes with the methodical mindset of a scientist rather than the wishful thinking of a believer. In 1973, he decided to take a fresh look at the data that had been puzzling researchers since Jürgen Haas first detected those impossible radio echoes back in 1927. Lunan's approach was innovative. Instead of trying to explain the echoes using conventional physics, he wondered if there might be a pattern hidden in the timing of the delays. He began plotting the delay times against the order in which the echoes were received, looking for any kind of structure or meaning in what appeared to be random data. What he found was extraordinary. When he graphed the signals, a pattern emerged that looked remarkably like a star map. Not just any star map, but one that seemed to point to a specific location in space, the double star system Epsilon Boötis, located about 210 light-years from Earth. According to Lunan's interpretation, the long-delayed echoes weren't random reflections off natural objects in space. They were signals from an ancient alien probe that had been placed in orbit around Earth thousands of years ago. The probe was supposedly programmed to respond to radio transmissions from Earth by sending back encoded messages containing information about its origin and purpose. Lunan calculated that the probe had arrived in our solar system approximately 13,000 years ago, sent by an advanced civilization from the Epsilon Boötis system. Its mission was to monitor Earth and wait for the development of radio technology, at which point it would begin transmitting information back to any civilization capable of receiving and decoding its signals. The theory was breathtaking in its scope and ambition. Here was a scientific explanation that tied together Tesla's mysterious signals from 1899, the long-delayed echoes detected since 1927, and the various reports of unknown objects in orbit. All of these phenomena could be explained by the presence of a single ancient artifact silently watching humanity from space. Lunan published his findings in the journal Spaceflight in April 1973, and the response was immediate and intense. UFO researchers embraced the theory as vindication of their beliefs about extraterrestrial visitation. Science fiction fans were fascinated by the idea of an ancient alien probe still functioning after millennia in space. Even some mainstream scientists found the mathematical analysis intriguing, even if they were skeptical about the conclusions. But there was a problem. Loonan had based his analysis on data from the 1920s, and some of that data turned out to be inaccurate. When he tried to verify his results using more recent and reliable measurements, the pattern that had seemed so clear began to fall apart. In 1976, just 3 years after his original publication, Loonan published a retraction. He admitted that his methods had been unscientific and that he had made fundamental errors in his analysis. The star map that had pointed to Epsilon Bootis was likely a product of selective interpretation rather than genuine alien communication. Loonan later said he regretted ever becoming associated with what he called the Black Knight satellite nonsense. He had approached the mystery as a legitimate scientific puzzle, but his work had been twisted and misrepresented by conspiracy theorists who ignored his retraction and continued to cite his original, flawed analysis as evidence for ancient alien visitation. But the damage was done. Loonan's 1973 paper had provided exactly what the growing Black Knight satellite legend needed. A scientific-sounding explanation that tied together decades of mysterious observations into a single compelling narrative. Even though Loonan himself had disavowed the theory, it continued to spread through UFO communities and conspiracy theory networks. The story now had all the elements of a classic conspiracy theory: ancient aliens, government cover-ups, mysterious signals, and objects in space that couldn't be explained by conventional science. It was a narrative that satisfied humanity's deep desire to believe we're not alone in the universe, while also explaining away the lack of obvious evidence for extraterrestrial contact. And then, 25 years later, NASA would inadvertently provide what many considered to be photographic proof of the Black Knight satellite's existence. In December 1998, the Space Shuttle Endeavour launched on mission STS-88, carrying the crew that would begin assembly of the International Space Station. It was a historic mission, representing the beginning of permanent human presence in space and international cooperation on an unprecedented scale. The crew consisted of 6 experienced astronauts, including mission specialists Jerry Ross and James Newman, who would conduct multiple spacewalks to connect the American Unity module with the Russian Zarya control module already in orbit. These spacewalks required precise coordination and careful handling of equipment in the unforgiving environment of space. During one of these spacewalks, the astronauts were installing thermal blankets on the exterior of the space station components. These blankets were crucial for protecting the station from the extreme temperature variations in space, where objects can experience temperature swings of hundreds of degrees between sunlight and shadow. The work was delicate and challenging. The thermal blankets were large, flexible sheets that had to be carefully positioned and secured to the station's exterior. In the weightless environment of space, even the slightest mistake could send equipment floating away into the void. And that's exactly what happened. During the installation process, one of the thermal blankets came loose from astronaut Jerry Ross's spacesuit and began drifting away from the space station. The conversation between Ross and Mission Commander Robert Cabana was captured on NASA's official communication recordings. "Jerry, one of the thermal covers got away from you," Cabana reported matter-of-factly. It was the kind of minor equipment loss that occasionally happens during spacewalks. Frustrating, but not dangerous. The blanket was already too far away to retrieve, so the astronauts continued with their work while Mission Control made note of the lost equipment for their official records. What the crew didn't realize at the time was that this lost thermal blanket would soon become one of the most famous pieces of space debris in UFO history. A few days later, as the space shuttle was preparing to return to Earth, crew members began photographing various objects and phenomena visible from their orbital vantage point. Among these photographs were several images of a dark, angular object floating in space some distance from the shuttle. The object was unlike anything most people had ever seen in space. Instead of the clean geometric lines of typical satellites or space station components, this object appeared twisted and irregular. It was dark, almost black, with what looked like complex angular surfaces that caught and reflected light in unusual ways. When these photographs were eventually released by NASA and made available to the public, UFO researchers immediately seized on them as evidence of the Black Knight satellite. Here, they argued, was photographic proof of the ancient alien probe that had been orbiting Earth for thousands of years. The images seemed to support many of the claims that had been made about the Black Knight satellite over the decades. The object was clearly artificial, but it didn't look like any known human-made satellite. Its dark color and irregular shape were consistent with descriptions of an ancient artifact that had been weathered by millennia of exposure to the harsh environment of space. UFO websites and conspiracy theory forums exploded with analysis of the photographs. Researchers enhanced the images, measured the object's apparent size, and speculated about its construction and purpose. Some claimed to see evidence of advanced alien technology in the object's design. Others pointed to its position and orientation as proof that it was under intelligent control, rather than simply drifting randomly through space. The photographs seemed to vindicate decades of speculation about mysterious objects in orbit. Here was visual evidence that couldn't be easily dismissed or explained away. The images had been taken by professional astronauts using official NASA equipment. They showed a real object in space that didn't match any known satellite or piece of space debris. But there was one person who wasn't impressed by the UFO community's analysis of the photographs. James Oberg, a former NASA engineer who had actually worked on the STS-88 mission. Oberg knew exactly what the mysterious object was because he had been involved in planning the mission's trajectory and had spoken directly with the astronauts who had taken the photographs. The dark, angular object that UFO researchers found so compelling was nothing more than the thermal blanket that had been lost during Jerry Ross's spacewalk. According to Oberg, the blanket's unusual appearance in the photographs was simply a result of how flexible materials behave in the weightless environment of space. Without gravity and air resistance to give it a familiar shape, the thermal blanket had twisted and folded into a configuration that looked artificial and structured when photographed from a distance. The dark color that conspiracy theorists found so mysterious was actually a normal characteristic of thermal blankets, which are often designed with dark surfaces to efficiently absorb or radiate heat. The angular geometric appearance that suggested advanced alien technology was simply the result of how a flexible sheet material responds to the complex forces and thermal conditions of space. Oberg's explanation was supported by the official NASA documentation of the mission, which clearly recorded the loss of the thermal blanket and tracked its subsequent orbit around Earth. The object was even assigned an official catalog number by NASA's Space Surveillance Network and was observed until it burned up in Earth's atmosphere a few days later. But for many UFO believers, Oberg's explanation was just another government cover-up designed to hide the truth about extraterrestrial visitation. They argued that it was too convenient for NASA to claim that one of the most compelling pieces of evidence for the Black Knight satellite was simply a lost piece of equipment from their own mission. The debate over the STS-88 photographs highlighted a fundamental problem with the Black Knight satellite theory. Every piece of evidence that supporters cite can be explained by conventional means, but believers consistently reject these explanations in favor of more exotic alternatives. Tesla's mysterious radio signals can be explained by natural astronomical phenomena that weren't understood in 1899. The long-delayed echoes remain puzzling, but don't require alien technology to explain. The mysterious objects detected in the 1950s and 1960s turned out to be misidentified pieces of human-made satellites. And the dramatic photographs from 1998 show nothing more than a lost thermal blanket tumbling through space. Yet the theory persists, growing stronger with each apparent debunking. In the age of the internet, conspiracy theories have found new life and new audiences. Social media platforms allow believers to share evidence, discuss theories, and reinforce each other's convictions without interference from skeptical scientists or government officials. The Black Knight satellite has become more than just a UFO theory. It's become a symbol of humanity's relationship with the unknown, our desire to believe we're not alone in the universe, and our deep suspicion of official explanations for mysterious phenomena. The story of the Black Knight satellite reveals something profound about human nature. We are pattern-seeking creatures, wired by evolution to find meaning in chaos and connections where none may exist. When we encounter phenomena that don't fit neatly into our understanding of the world, our minds automatically begin constructing narratives to make sense of the unexplained. This psychological tendency becomes even more pronounced when we're dealing with the vastness of space. There's something about the infinite darkness above our heads that triggers our deepest fears and our greatest hopes. We want to believe that we're not alone, that somewhere among the billions of stars, other intelligent beings are looking back at us with the same mixture of curiosity and longing. The Black Knight satellite theory taps into these primal emotions in a way that purely rational explanations simply cannot. When someone shows you a photograph of a strange object in space and tells you it's an ancient alien probe that's been watching humanity for 13,000 years, that narrative carries an emotional weight that no amount of technical discussion about thermal blankets can match. But there's another factor at play here, one that's become increasingly important in our digital age. The democratization of information has fundamentally changed how conspiracy theories spread and evolve. In the past, fringe theories were confined to specialized publications and small communities of believers. Today, anyone with an internet connection can access decades of accumulated research, analysis, and speculation about mysterious phenomena. Social media algorithms designed to maximize engagement tend to show people content that confirms their existing beliefs and interests. If you click on one video about the Black Knight satellite, you'll soon be recommended dozens more. If you join one forum discussing ancient aliens, you'll be invited to others. The result is the creation of information bubbles, where believers can immerse themselves in supporting evidence while rarely encountering serious challenges to their worldview. This digital echo chamber effect helps explain why conspiracy theories like the Black Knight satellite continue to thrive, despite repeated debunking by scientists and space agencies. Each piece of evidence that gets explained away is simply dismissed as part of a larger cover-up, while new pieces of supporting evidence continue to emerge from the vast archives of space photography and historical documents available online. Consider how the theory has evolved since its inception. What began as Tesla's puzzling radio signals has grown into an elaborate mythology that incorporates everything from ancient astronaut theories to modern UFO sightings. Believers have connected the Black Knight satellite to other mysterious phenomena like the WOW, signal detected by SETI researchers in 1977, unexplained objects in historical artwork, and even recent Navy videos of unidentified aerial phenomena. This process of accretion, where unrelated mysterious events get absorbed into a larger narrative, is a hallmark of successful conspiracy theories. The Black Knight satellite has become a kind of conceptual black hole, pulling in any unexplained space-related phenomena and adding them to its growing mythology. Each new addition makes the overall theory seem more credible to believers. even though the individual pieces of evidence remain just as explainable by conventional means. The persistence of the Black Knight satellite theory also reflects a deeper skepticism about authority and official explanations that has become increasingly common in modern society. When NASA says the mysterious object in their photographs is a lost thermal blanket, many people automatically assume there must be more to the story. After all, they reason, if there really was evidence of alien technology in orbit, wouldn't the government want to keep it secret? This assumption of secrecy and cover-up is self-reinforcing. Any official denial becomes evidence of the conspiracy, while any lack of official comment is interpreted as suspicious silence. The theory becomes unfalsifiable, immune to contradiction, because contradictory evidence is automatically reinterpreted as proof of deception. The intelligence community's historical involvement in UFO research has unfortunately provided some justification for this skepticism. Declassified documents have revealed that government agencies have indeed studied UFO reports, sometimes while publicly denying any interest in the phenomenon. Programs like Project Blue Book, Project Sign, and more recently, the Pentagon's Advanced Aerospace Threat Identification Program show that official statements about UFO investigations haven't always been entirely truthful. This documented history of secrecy around unexplained aerial phenomena makes it easier for people to believe that similar secrecy might surround mysterious objects in space. If the government has lied about UFOs in the past, the reasoning goes, why should we trust their explanations about mysterious satellites now? But there's an important distinction to be made here between healthy skepticism and conspiratorial thinking. Questioning official explanations and demanding evidence is a crucial part of scientific inquiry. The problem arises when skepticism becomes so absolute that no amount of evidence can change someone's mind, and when every piece of contradictory information is automatically dismissed as part of a cover-up. The scientific method works precisely because it includes mechanisms for self-correction. When new evidence emerges that contradicts existing theories, scientists are supposed to revise their understanding accordingly. This is exactly what happened with Duncan Loonan's analysis of the long-delayed echoes. When he discovered errors in his methodology, he publicly retracted his conclusions, even though doing so undermined a theory he had spent years developing. This willingness to admit mistakes and revise conclusions is one of the key differences between scientific thinking and conspiratorial thinking. In science, being wrong is unfortunate but acceptable, as long as you're willing to change your position when presented with better evidence. In conspiracy theories, being wrong is often impossible by definition, because the theory is structured in such a way that any contradictory evidence can be explained away. The Black Knight satellite theory demonstrates this dynamic perfectly. When Tesla's radio signals were explained as natural astronomical phenomena, believers didn't abandon the theory. They simply argued that the scientific explanations were incomplete or deliberately misleading. When the mysterious 1960 satellite was identified as American space debris, supporters claimed this was a cover story. When the STS-88 photographs were revealed to show a lost thermal blanket, believers insisted this was another government lie. Each debunking becomes part of the conspiracy, proof that powerful forces are working to hide the truth. The theory grows stronger with each challenge, like a virus that mutates to resist antibiotics. This adaptive quality helps explain why the Black Knight satellite legend has survived and thrived for more than a century, despite the absence of any credible supporting evidence. Yet even as we recognize the psychological and sociological factors that sustain conspiracy theories, we shouldn't dismiss the genuine mysteries that often serve as their foundation. The long-delayed echoes detected by Jürgen Holz and confirmed by other researchers remain unexplained to this day. While we can be confident they don't represent alien communication, we still don't fully understand what causes radio signals to be delayed by several seconds when bouncing off unknown objects in space. Similarly, while the STS-88 photographs clearly show a lost thermal blanket rather than an alien artifact, they also demonstrate how easy it is for ordinary objects to appear extraordinary under the unusual conditions of space. The thermal blanket's twisted, angular appearance in those images is genuinely striking and unlike anything most people have seen before. It's not unreasonable for someone unfamiliar with the circumstances of the photograph to wonder if they're looking at something artificial and possibly alien. These genuine mysteries and ambiguities provide the kernel of truth around which conspiracy theories crystallize. The mistake that believers make is not in questioning official explanations or noticing unexplained phenomena. The mistake is in jumping too quickly to extraordinary conclusions and then refusing to revise those conclusions when more mundane explanations emerge. The scientific approach to mystery is different. It acknowledges that we don't know everything and that unexplained phenomena deserve serious investigation. But it also recognizes that extraordinary claims require extraordinary evidence and that the most exotic explanation is rarely the correct one. When faced with a mystery, scientists try to rule out ordinary explanations before considering extraordinary ones. This methodical approach has served us well in understanding the universe around us. It's how we've learned to distinguish between genuine astronomical phenomena and instrumental artifacts, between natural radio signals and artificial ones, between real unexplained objects and misidentified conventional ones. It's a slower and less exciting process than jumping immediately to alien explanations, but it's also more reliable. The Black Knight satellite theory will likely continue to evolve and persist, regardless of how thoroughly its claims are debunked. New generations of believers will discover the story online, find it compelling, and add their own interpretations and evidence to the growing mythology. The theory satisfies too many psychological needs and fits too well with our digital information environment to simply disappear. But perhaps that's not entirely a bad thing. While the specific claims about an ancient alien probe are almost certainly false, the broader questions raised by the Black Knight satellite theory are genuinely important. Are we alone in the universe? How would we recognize evidence of extraterrestrial intelligence if we encountered it? What should we make of unexplained phenomena that don't fit our current understanding of the world? These are questions that serious scientists are actively investigating through programs like SETI, the search for exoplanets, and the study of potentially habitable worlds around other stars. The difference is that scientists are approaching these questions methodically, using rigorous standards of evidence and peer review to separate genuine discoveries from wishful thinking. The story of the Black Knight satellite serves as a cautionary tale about the importance of critical thinking in an age of information overload. It shows us how easy it is for unrelated events to be woven into compelling narratives, how confirmation bias can lead us to see patterns that don't really exist, and how the desire to believe can override our capacity for rational analysis. But it also demonstrates the enduring power of mystery and the human need to find meaning in the unknown. Even if the Black Knight satellite doesn't exist, the questions it represents about our place in the cosmos and our relationship with the unknown remain as relevant today as they were when Tesla first detected those mysterious signals more than a century ago. As we continue to explore space and search for signs of life beyond Earth, we'll undoubtedly encounter new mysteries and unexplained phenomena. The challenge will be to investigate these mysteries with the same rigor and skepticism that science demands, while remaining open to the possibility that some of them might represent genuinely revolutionary discoveries. The Black Knight satellite may be a myth, but the questions it raises about alien intelligence, government secrecy, and the nature of unexplained phenomena are very real. And in a universe as vast and mysterious as ours, those questions deserve serious answers, even if the answers turn out to be less exotic than the conspiracy theorists would have us believe. The search for truth whether about mysterious satellites or anything else, requires patience, skepticism, and intellectual honesty. It means being willing to admit when we're wrong, to revise our theories when new evidence emerges, and to distinguish between what we want to believe and what the evidence actually supports. In the end, the real mystery isn't whether there's an ancient alien probe orbiting Earth. The real mystery is how we can maintain our sense of wonder about the universe while still thinking critically about the claims we encounter. The Black Knight satellite theory may not give us aliens, but it does give us an important lesson about the relationship between mystery and truth in the modern world. Whether we're looking at mysterious radio signals from over a century ago, unexplained satellite detections during the Cold War, or dramatic photographs from space missions, each piece of the Black Knight puzzle reveals something important about how we process information and construct meaning from incomplete data. The power of the Black Knight satellite story lies not just in its exotic claims, but in how it reflects our deepest anxieties and aspirations about space exploration and our place in the universe. We live in an era where we've sent probes to the edge of the solar system, landed rovers on Mars, and detected thousands of exoplanets orbiting distant stars. Yet despite all these achievements, we still haven't answered the fundamental question that drives much of our space exploration. Are we alone? This uncertainty creates a psychological tension that conspiracy theories are perfectly designed to resolve. The Black Knight satellite offers a definitive answer to the question of extraterrestrial life, complete with a timeline, a purpose, and even photographic evidence. It provides closure in a way that the methodical, uncertain process of scientific discovery simply cannot. But there's another dimension to this story that's worth considering. The persistence of the Black Knight satellite theory also reflects genuine shortcomings in how scientific institutions communicate with the public about space-related mysteries and discoveries. When NASA releases photographs of unusual objects in space, they often provide minimal context or explanation. Technical descriptions written for other scientists don't translate well to public understanding, leaving room for alternative interpretations to flourish. The space agency's tendency toward bureaucratic language and cautious statements can make even straightforward explanations sound evasive or incomplete. Take the STS-88 thermal blanket incident as an example. While NASA did document the loss of equipment during the spacewalk, this information wasn't immediately connected to the photographs of the mysterious object when they were released to the public. It took the intervention of James Oberg, working independently, to make the connection clear and provide the context that should have accompanied the images from the beginning. This communication gap between scientific institutions and the public creates opportunities for alternative narratives to take root. When official explanations are delayed, incomplete, or difficult to understand, people naturally begin developing their own theories to fill the void. And once those alternative theories become established, they can be remarkably resistant to correction. The democratization of information through the internet has dramatically amplified this effect. In the past, space-related mysteries might be discussed in specialized publications or academic journals, reaching relatively small audiences of scientists and enthusiasts. Today, a single photograph or video clip can be shared millions of times within hours, analyzed by thousands of amateur researchers, and incorporated into elaborate theories that spread faster than official explanations can keep up. This dynamic has fundamentally changed how modern conspiracy theories develop and spread. The Black Knight satellite legend evolved slowly over decades, incorporating new elements as they became available. Contemporary conspiracy theories can explode into public consciousness almost instantly, driven by social media algorithms that prioritize engagement over accuracy. The psychological appeal of the Black Knight satellite theory is enhanced by its connection to broader cultural narratives about ancient astronauts and lost civilizations. The idea that advanced beings visited Earth in the distant past and left behind evidence of their presence taps into the same romantic notion that drives our fascination with archaeological mysteries and lost knowledge. This cultural context helps explain why the 13,000-year timeline proposed by Duncan Lunan resonated so strongly with believers. It places the alleged alien probe's arrival roughly contemporary with the end of the last ice age and the development of agriculture and civilization. The timing suggests a connection between extraterrestrial intervention and humanity's rapid technological and social development, a narrative that has deep roots in mythology and religion. The Black Knight satellite becomes, in this interpretation, not just evidence of alien visitation, but proof of alien guidance or intervention in human development. It transforms from a simple monitoring device into a symbol of humanity's cosmic significance, suggesting that our species has been of interest to advanced beings for millennia. This elevation of human importance is psychologically appealing in a universe that often seems indifferent to our existence. When we look up at the night sky and contemplate the vast distances between stars, the age of the cosmos, and the apparent rarity of life, it's natural to feel small and insignificant. The Black Knight satellite theory offers reassurance that we matter, that we're being watched, that our development as a species is part of some larger cosmic plan. But this psychological comfort comes at a cost. By embracing extraordinary explanations for ordinary phenomena, we risk losing our capacity for critical thinking and scientific reasoning. We become susceptible to other unfounded beliefs and conspiracy theories, creating a worldview that's increasingly disconnected from evidence-based reality. The challenge for science educators and communicators is finding ways to preserve the sense of wonder and cosmic significance that draws people to theories like the Black Knight satellite, while redirecting that enthusiasm toward genuine scientific discovery and exploration. The real universe revealed by astronomy and space exploration is far more amazing than any conspiracy theory. We live on a planet orbiting a star that's one of hundreds of billions in our galaxy, which is itself one of hundreds of billions of galaxies in the observable universe. We've discovered planets made of diamond, stars that spin hundreds of times per second, and black holes with masses billions of times that of our Sun. We've detected gravitational waves from colliding black holes, observed the formation of the first galaxies in the early universe, and found evidence of liquid water on multiple worlds in our own solar system. We've sent spacecraft to every planet in the solar system and beyond, creating a technological extension of human presence that spans billions of miles. These genuine achievements and discoveries offer the same sense of cosmic wonder and significance that conspiracy theories promise, but they're grounded in evidence and observation rather than speculation and wishful thinking. They represent humanity's actual expansion into the cosmos rather than imagined visitation from elsewhere. The search for extraterrestrial life continues through legitimate scientific channels. Projects like SETI scan the sky for artificial radio signals, while astronomers study the atmospheres of exoplanets, looking for chemical signatures that might indicate biological activity. Space missions explore the subsurface oceans of moons like Europa and Enceladus, searching for environments where life might exist. These efforts may eventually provide the definitive answer to the question of whether we're alone in the universe, but they're proceeding methodically, with careful attention to evidence and rigorous peer review. They may not provide the immediate satisfaction of conspiracy theories, but they offer something more valuable: reliable knowledge about our cosmic environment. The Black Knight satellite theory will likely persist regardless of how thoroughly it's been debunked, because it serves psychological and social functions that have little to do with its factual accuracy. It provides community for believers, meaning for those seeking cosmic significance, and resistance to authority for those suspicious of official explanations. Understanding these underlying motivations is crucial for anyone trying to promote scientific literacy and critical thinking. Simply presenting facts and evidence isn't enough to change minds that have been shaped by deeper psychological needs and social pressures. Effective science communication must address these underlying concerns while providing alternative ways to satisfy the human need for wonder, community, and meaning. The story of the Black Knight satellite offers valuable lessons for how we approach mystery and uncertainty in an age of information abundance. It shows us the importance of distinguishing between genuine scientific puzzles and manufactured controversies, between healthy skepticism and paranoid thinking, between wonder and wishful thinking. As we continue to explore space and search for signs of life beyond Earth, we'll undoubtedly encounter new phenomena that challenge our understanding and defy easy explanation. Some of these discoveries may indeed revolutionize our view of the universe and our place within it, but distinguishing genuine breakthroughs from false alarms will require the same careful, methodical approach that has guided scientific progress for centuries. The Black Knight satellite may not exist, but the questions it represents about alien intelligence, space exploration, and the nature of mystery remain as compelling today as they were when Tesla first detected those puzzling radio signals over a century ago. The difference is that we now have the tools and knowledge to investigate these questions systematically, following the evidence wherever it leads, rather than jumping to conclusions based on incomplete information and wishful thinking. In the end, the real Black Knight satellite isn't an ancient alien probe orbiting Earth. It's the human capacity for curiosity, wonder, and exploration that drives us to ask difficult questions about the universe and our place within it. That capacity has taken us from Tesla's primitive radio receivers to sophisticated space telescopes capable of detecting Earth-like planets around distant stars. It's what will ultimately answer the question of whether we're alone in the universe, regardless of what that answer turns out to be. The mystery of the Black Knight satellite reminds us that truth is often more complex and nuanced than either believers or skeptics want to acknowledge. While the specific claims about an ancient alien probe are almost certainly false, the broader questions about unexplained phenomena, government transparency, and the search for extraterrestrial life remain genuinely important and worthy of serious investigation. The challenge moving forward is maintaining our sense of wonder about the cosmos while developing better tools for distinguishing between genuine mysteries worth investigating and manufactured controversies that distract from real scientific progress. The Black Knight satellite story shows us both the perils and the promise of human curiosity in an age when information travels faster than understanding, and when the line between fact and fiction becomes increasingly blurred. As we stand on the threshold of an era that may finally answer the age-old question of whether we're alone in the universe, the lessons learned from the Black Knight satellite legend become more important than ever. The way we handle mystery, evaluate evidence, and communicate scientific findings will determine whether future discoveries lead to genuine understanding or simply spawn new generations of unfounded conspiracy theories. The Black Knight satellite may be a myth, but the human drive to explore, question, and seek meaning in the vast darkness of space is very real. That drive has already taken us further than our ancestors could have imagined, and it will continue to push the boundaries of knowledge and exploration for generations to come. The question is whether we'll use that drive to pursue genuine understanding or lose ourselves in comfortable fantasies about ancient alien watchers in the sky. The choice, like the mystery itself, remains ours to make. But perhaps the most significant aspect of the Black Knight satellite phenomenon isn't what it tells us about alien visitation. It's what it reveals about the modern information landscape and how extraordinary claims can persist and evolve in the digital age. consider how the story has transformed since its early days. Tesla's radio signals, detected in an era when the possibility of life on Mars and Venus seemed scientifically plausible, have been reinterpreted through decades of advancing technology and changing cultural context. What began as one man's genuine attempt to understand mysterious radio phenomena has become a cornerstone of modern UFO mythology. The evolution of the Black Knight legend mirrors the broader transformation of how information spreads in our interconnected world. In Tesla's time, scientific discoveries were communicated through formal papers, professional journals, and academic conferences. The process was slow, deliberate, and subject to peer review. Extraordinary claims faced immediate scrutiny from qualified experts who could evaluate the methodology and reproduce the experiments. Today, that careful gatekeeping system has largely collapsed. A single photograph or video clip can circle the globe within hours, analysed and reanalyzed by millions of people with varying levels of expertise. Social media algorithms amplify content that generates engagement, regardless of its accuracy. The result is an information ecosystem where compelling narratives often spread faster than the facts needed to evaluate them. This dynamic has fundamentally altered how conspiracy theories develop and persist. The Black Knight satellite story took decades to mature, slowly accumulating evidence and evolving its central claims. Modern conspiracy theories can explode into public consciousness almost instantly, driven by viral videos and social media sharing that outpaces any attempt at verification or debunking. The psychological factors that make the Black Knight satellite theory appealing haven't changed, but the mechanisms for spreading and reinforcing those beliefs have been revolutionized. Online communities allow believers to find each other, share evidence, and develop increasingly elaborate theories without encountering serious challenges to their worldview. The algorithm-driven nature of modern media consumption creates what researchers call filter bubbles, where people are primarily exposed to information that confirms their existing beliefs. If you watch one video about the Black Knight satellite, you'll be recommended dozens more. If you join one forum discussing ancient aliens, you'll be invited to others. The result is an immersive environment where extraordinary claims seem ordinary because they're constantly reinforced by like-minded communities. This echo chamber effect helps explain why debunking efforts often fail to change minds. When NASA explains that the STS-88 photographs show a lost thermal blanket, believers don't abandon their theory. Instead, they interpret the explanation as evidence of a cover-up, proof that powerful forces are working to hide the truth. Each debunking becomes part of the conspiracy, making the theory stronger rather than weaker. The persistence of the Black Knight satellite legend also reflects broader changes in how people relate to authority and expertise. In an era of declining trust in institutions, official explanations are automatically suspect. When space agencies or scientists provide mundane explanations for mysterious phenomena, many people assume there must be more to the story. This skepticism isn't entirely unreasonable. Declassified documents have revealed that government agencies have indeed studied UFO reports while publicly denying interest in the phenomenon. Programs like Project Blue Book and the more recent Pentagon UAP investigations show that official statements about unexplained aerial phenomena haven't always been truthful. However, there's an important distinction between healthy skepticism and paranoid thinking. Questioning official explanations and demanding evidence is crucial for democratic society and scientific progress. The problem arises when skepticism becomes so absolute that no amount of evidence can change someone's mind, and when every piece of contradictory information is automatically dismissed as part of a cover-up. The Black Knight satellite theory demonstrates this dynamic perfectly. Supporters have developed an unfalsifiable belief system where any evidence against their claims is reinterpreted as proof of deception. Tesla's radio signals weren't natural phenomena, but alien communication. The 1960 satellite detection wasn't misidentified space debris, but a cover story. The STS-88 photographs don't show a thermal blanket, but an alien artifact that NASA is lying about. This adaptive quality helps explain why the theory has survived more than a century of technological advancement and scientific explanation. Like a virus that mutates to resist antibiotics, the Black Knight legend evolves to incorporate new information while maintaining its core claims about ancient alien surveillance. Yet even as we recognize the psychological and sociological factors that sustain conspiracy theories, we shouldn't dismiss the genuine scientific puzzles that often serve as their foundation. The long-delayed echoes detected by Jürgen Hals remain unexplained nearly a century later. While we can be confident they don't represent alien communication, we still don't fully understand what causes radio signals to be delayed by several seconds when bouncing off unknown objects in space. Modern research has proposed various explanations for LDEs, including reflections off ionized meteor trails, interactions with plasma clouds in the Earth's magnetosphere, and even quantum mechanical effects in the ionosphere. But none of these theories fully account for all the observed characteristics of the phenomenon. The mystery persists, providing a genuine scientific puzzle that deserves continued investigation. Similarly, while the STS-88 photographs clearly show a lost thermal blanket rather than an alien artifact, they also demonstrate how ordinary objects can appear extraordinary under the unusual conditions of space. The weightless environment, extreme temperature variations, and unique lighting conditions in orbit can transform familiar materials into shapes and configurations that seem impossible to earthbound observers. These genuine mysteries and ambiguities provide the kernel of truth around which conspiracy theories crystallize. The mistake that believers make isn't in questioning official explanations or noticing unexplained phenomena. The mistake is in jumping too quickly to extraordinary conclusions, and then refusing to revise those conclusions when more prosaic explanations emerge. The scientific approach to mystery is fundamentally different. It acknowledges uncertainty and embraces the possibility that we don't understand everything about the universe. But it also recognizes that extraordinary claims require extraordinary evidence, and that the most exotic explanation is rarely the correct one. When faced with unexplained phenomena, scientists work methodically to rule out ordinary explanations before considering extraordinary ones. This process can be slow and frustrating, especially for those eager to confirm their beliefs about alien visitation or government conspiracies. But it's also more reliable than jumping immediately to sensational conclusions. The methodical nature of scientific investigation has served us well in distinguishing between genuine discoveries and instrumental artifacts, between natural phenomena and artificial signals, between real, unexplained objects and misidentified conventional ones. It's how we've learned to separate the wheat from the chaff in our exploration of the cosmos. This careful approach becomes even more important as our technology advances and our ability to detect faint signals and distant objects improves. The same sensitivity that allows us to discover exoplanets and detect gravitational waves also makes us more susceptible to false positives and instrumental glitches that could be misinterpreted as evidence of extraterrestrial intelligence. The ongoing search for extraterrestrial life through projects like SETI demonstrates how genuine scientific investigation of these questions proceeds. Radio telescopes scan the sky for artificial signals, but researchers are careful to rule out terrestrial interference, instrumental problems, and natural astrophysical sources before claiming detection of alien intelligence. When the WOW signal was detected in 1977, astronomers didn't immediately announce the discovery of extraterrestrial civilization. Instead, they spent decades trying to reproduce the observation, understand its characteristics, and determine whether it could have natural or artificial origins. The signal remains unexplained, but it's treated as a genuine scientific mystery rather than proof of alien contact. This cautious approach may seem less exciting than the dramatic claims of Black Knight satellite believers, but it's more likely to lead to genuine discoveries. If and when we do detect evidence of extraterrestrial intelligence, it will come through careful observation and rigorous analysis, rather than wishful interpretation of ambiguous data. The persistence of the Black Knight satellite theory in an age of advancing space technology and improving scientific understanding raises important questions about science communication and public education. How can we maintain public interest in space exploration while promoting critical thinking about extraordinary claims? Part of the answer lies in better communication from scientific institutions. When space agencies release photographs of unusual objects or announce the detection of unexplained phenomena, they need to provide immediate context and explanation rather than leaving the public to develop their own interpretations. The delayed response to the STS-88 photographs allowed conspiracy theories to take root and spread before official explanations could catch up. Scientists and educators also need to acknowledge the legitimate human desires that drive people toward conspiracy theories. The need for wonder, meaning, and cosmic significance are powerful motivations that shouldn't be dismissed or ignored. Instead, they should be redirected toward genuine scientific discoveries and exploration. The real universe revealed by astronomy and space science is far more amazing than any conspiracy theory. We live in a cosmos filled with black holes and neutron stars, exoplanets and supernovae, dark matter and dark energy. We've sent spacecraft to the edge of the solar system and detected gravitational waves from colliding black holes billions of light years away. These genuine achievements offer the same sense of wonder and cosmic significance that conspiracy theories promise, but they're grounded in evidence and observation rather than speculation and wishful thinking. They represent humanity's actual expansion into the cosmos rather than imagined visitation from elsewhere. The challenge for science educators is communicating these genuine wonders in ways that capture public imagination while maintaining scientific rigor. This means being honest about uncertainty and acknowledging that we don't have all the answers, while also explaining why scientific methods are more reliable than intuition or wishful thinking for understanding the natural world. Education systems also need to do better at teaching critical thinking skills that can help people evaluate extraordinary claims and distinguish between reliable and unreliable sources of information. In an age where anyone can publish content online, and algorithmic amplification can make fringe theories seem mainstream, these skills become essential for navigating the modern information landscape. The Black Knight satellite story offers a perfect case study for teaching these skills. Students can examine the historical development of the theory, evaluate the quality of evidence presented by supporters, understand how scientific explanations address the mysteries, and recognize the psychological and social factors that make conspiracy theories appealing. By understanding how the Black Knight legend developed and persisted, despite repeated debunking, students can develop the analytical tools needed to evaluate other extraordinary claims they'll encounter throughout their lives. They can learn to distinguish between genuine scientific mysteries worth investigating and manufactured controversies that distract from real discovery. The lessons learned from the Black Knight satellite phenomenon become increasingly important as we enter an era that may finally answer fundamental questions about life in the universe. Missions to Mars are searching for signs of past or present microbial life. Space telescopes are analyzing the atmospheres of exoplanets, looking for biosignatures. Radio telescopes continue scanning for artificial signals from distant civilizations. These investigations may eventually provide the definitive evidence for extraterrestrial life that humanity has sought for generations. But when that evidence emerges, it will need to be evaluated carefully and communicated clearly to avoid the kind of confusion and misinterpretation that has surrounded the Black Knight satellite for more than a century. The way we handle future discoveries will depend on how well we've learned to balance wonder with skepticism, enthusiasm with rigor, and hope with critical thinking. The Black Knight satellite story shows us both the perils and the promise of human curiosity in an age when information travels faster than understanding. As we continue pushing the boundaries of space exploration and searching for our place in the cosmic community, we'll undoubtedly encounter new phenomena that challenge our understanding and defy easy explanation. Some of these discoveries may indeed revolutionize our view of the universe and our relationship to it, but distinguishing genuine breakthroughs from false alarms will require the same methodical approach that has guided scientific progress for centuries. The Black Knight satellite may be a myth, but the human drive to explore, question, and seek meaning in the vast darkness of space is very real. That drive has already taken us further than our ancestors could have imagined, from Tesla's primitive radio experiments to sophisticated space telescopes capable of detecting Earth-like worlds around distant stars. The question isn't whether we'll continue exploring and discovering. The question is whether we'll use our natural curiosity to pursue genuine understanding or lose ourselves in comfortable fantasies about ancient watchers in the sky. The choice, like the mystery itself, remains ours to make as we stand on the threshold of potentially answering one of humanity's oldest and most profound questions. Are we alone in the universe? The Black Knight satellite legend will likely persist regardless of what genuine discoveries await us among the stars. But understanding why it persists and what it tells us about human nature and modern information systems may be just as important as any alien signal we might someday detect. Because in the end, the most interesting mystery isn't whether there are ancient alien probes orbiting Earth. It's how we process mystery itself in an age of infinite information and finite wisdom. The story continues to evolve, adapt, and spread through digital networks that Tesla could never have imagined when he first detected those puzzling signals in the Colorado darkness more than a century ago. And somewhere in that evolution lies a deeper truth about humanity's relationship with the unknown, one that may prove more significant than any satellite, ancient or otherwise, could ever be. So far, we've traced the Black Knight satellite legend through more than a century of mysterious signals, unexplained echoes, and controversial photographs. But there's one aspect of this story that deserves deeper examination, something that reveals as much about human nature as it does about the alleged alien probe itself. Why do some people find the Black Knight satellite theory so compelling that they'll reject every scientific explanation in favor of an ancient alien origin? What is it about this particular conspiracy theory that allows it to survive and thrive despite decades of debunking? The answer lies in understanding how our brains process information, especially when that information challenges our existing beliefs or threatens our sense of security and meaning in the universe. Cognitive scientists have identified several mental shortcuts, called heuristics, that help us make sense of complex information quickly. These shortcuts served our ancestors well when making split-second decisions about predators or food sources, but they can lead us astray when evaluating modern scientific claims. One of the most powerful of these shortcuts is called the availability heuristic. We tend to judge the likelihood of events based on how easily we can recall examples of them happening. If you've seen dozens of movies about alien invasions, if you've read countless stories about government cover-ups, if you've watched hours of documentaries about ancient astronauts, then the idea of an alien satellite monitoring Earth feels familiar and plausible. The Black Knight satellite theory benefits enormously from this cultural preparation. We live in a world saturated with science fiction narratives about extraterrestrial visitation, government conspiracies, and ancient mysteries. These stories have primed our minds to accept the possibility that reality might be stranger and more exciting than official sources admit. Another cognitive bias that plays a crucial role is confirmation bias, our tendency to search for, interpret, and remember information in ways that confirm our existing beliefs. Once someone becomes convinced that the Black Knight satellite exists, they unconsciously begin filtering information to support that belief. This filtering process is remarkably sophisticated. Supporters of the theory don't ignore contradictory evidence entirely. Instead, they reinterpret it in ways that actually strengthen their conviction. When NASA explains that the STS-88 photographs show a thermal blanket, believers don't see this as refutation of their theory. They see it as proof that NASA is lying, which confirms their suspicion that powerful forces are working to hide the truth. The pattern recognition systems in our brains also contribute to the theory's appeal. Humans are extraordinarily good at finding patterns, even in random data. This ability helped our ancestors survive by detecting subtle signs of danger or opportunity in their environment. But it also makes us susceptible to seeing meaningful connections where none actually exist. The Black Knight satellite legend is essentially a pattern that believers have imposed on a century of unrelated events. Tesla's radio signals, House's delayed echoes, Kehoe's satellite claims, the 1960 Navy detection, and the STS-88 photographs don't actually form a coherent narrative. But our pattern-seeking minds can connect these disparate events into what feels like a compelling story about ancient alien surveillance. This tendency to construct narratives from disconnected events is so fundamental to human cognition that psychologists have given it a name: apophenia. It's the same mental process that makes us see faces in clouds, hear voices in static, or find hidden messages in random text. In most contexts, this pattern-seeking behavior is harmless or even beneficial, but when applied to complex scientific questions, it can lead us far from the truth. The emotional appeal of the Black Knight satellite theory also plays a crucial role in its persistence. Conspiracy theories often serve important psychological functions, providing believers with a sense of special knowledge, community belonging, and protection against an uncertain world. Consider what the Black Knight satellite represents to its supporters. It's not just evidence of alien life, though that would be remarkable enough. It's proof that humanity is special, that we've been watched and monitored by advanced beings for thousands of years. It suggests that our development as a species is part of some larger cosmic plan, that we matter in ways that extend far beyond our small planet. This message is psychologically comforting in a universe that often seems indifferent to human existence. When we contemplate the vast distances between stars, the age of the cosmos, and the apparent rarity of life, it's natural to feel small and insignificant. The Black Knight satellite theory offers reassurance that we're not alone, that we're not forgotten, that someone or something is paying attention to our progress. The theory also provides a framework for understanding why the world often seems chaotic and unjust. If powerful elites are conspiring to hide evidence of alien visitation, then many of society's problems can be attributed to this deception, rather than to complex systemic issues that resist simple solutions. The conspiracy becomes a lens through which all other events can be interpreted and understood. But perhaps most importantly, believing in the Black Knight satellite makes people feel like they possess secret knowledge that others lack. In a world where many people feel powerless and uninformed, conspiracy theories offer the appealing illusion of being among the enlightened few who understand what's really happening. This sense of special knowledge is reinforced by the online communities that have formed around the theory. Social media platforms and discussion forums allow believers to find like-minded individuals, share evidence, and develop increasingly elaborate versions of the basic narrative. These communities provide social support and validation that makes it easier to maintain beliefs that are rejected by mainstream society. The group dynamics within conspiracy theory communities also tend to push members toward more extreme positions over time. Social psychologists call this phenomenon group polarization. When people with similar views discuss an issue together, they typically end up holding more extreme versions of their initial positions than they would have reached individually. In Black Knight satellite communities, this means that moderate skepticism about official explanations gradually evolves into absolute certainty that the government is lying about everything space-related. Members compete to uncover new evidence and develop more sophisticated theories, creating an escalating spiral of increasingly elaborate claims. The digital age has dramatically amplified these community effects. In the past, conspiracy theorists were often isolated individuals who struggled to find others who shared their beliefs. Today, even the most fringe theories can attract thousands of supporters who can communicate instantly across vast distances. The internet has created a global conspiracy theory ecosystem where ideas can spread and evolve at unprecedented speed. Search engine algorithms and social media recommendation systems inadvertently contribute to this process by creating what researchers call filter bubbles. If you search for information about the Black Knight satellite, you'll primarily find content created by believers rather than scientific debunking. If you watch one conspiracy theory video, you'll be recommended dozens more. The algorithmic curation of information creates an environment where extraordinary claims seem ordinary because they're constantly reinforced. This technological amplification helps explain why conspiracy theories like the Black Knight satellite have become more prominent and persistent in recent years. The theories themselves haven't necessarily become more credible, but the mechanisms for spreading and reinforcing them have become vastly more powerful. The persistence of the Black Knight satellite theory also reflects deeper changes in how people relate to authority and expertise in modern society. Trust in institutions has declined significantly over the past several decades, partly due to legitimate revelations about government deception and corporate malfeasance. When people discover that officials have lied about issues like weapons of mass destruction, surveillance programs, or pharmaceutical safety, they become more skeptical of all official pronouncements. This skepticism can be healthy when it leads to more critical evaluation of claims from authority figures, but it becomes problematic when it evolves into a reflexive rejection of all expert knowledge. The Black Knight satellite theory thrives in this environment of institutional distrust. When NASA provides technical explanations for mysterious space photographs, many people automatically assume there must be more to the story. The agency's history of secrecy around military space programs makes it easier to believe that they might also be hiding evidence of alien visitation. This suspicion is reinforced by the documented history of government involvement in UFO research. Declassified documents have revealed programs like Project Blue Book, Project Sign, and the more recent Pentagon UAP investigations. These programs show that official denials of interest in unexplained aerial phenomena haven't always been truthful. However, there's an important distinction between acknowledging that governments sometimes conceal information and assuming that every official explanation is false. The existence of some genuine secrets doesn't mean that all conspiracy theories are correct. But for people who have lost faith in institutional honesty, this distinction can be difficult to maintain. The psychological factors that make conspiracy theories appealing are further amplified by the way human memory works. Our recollections aren't perfect recordings of past events. Instead, they're reconstructive processes that can be influenced by our current beliefs and expectations. When believers in the Black Knight satellite theory recall learning about Tesla's radio signals or seeing the STS-88 photographs for the first time. Their memories are likely coloured by everything they've learned about the theory since then. Details that seemed mundane at the time may be remembered as more mysterious or significant. Contradictory information may be forgotten or minimized. This reconstructive nature of memory helps explain why personal testimonies about extraordinary events can be so compelling to believers while remaining unconvincing to skeptics. The people sharing these testimonies aren't necessarily lying, but their recollections may be less reliable than they realize. The emotional intensity associated with conspiracy theories also affects memory formation and retention. Events that trigger strong emotional responses are more likely to be remembered vividly, even if the details are inaccurate. This is why many people have crystal clear memories of where they were during major historical events, even though research shows these memories are often substantially wrong. For Black Knight satellite believers, discovering evidence of the alleged alien probe can be an emotionally powerful experience. The excitement of uncovering hidden truth, the fear of government deception, and the wonder of potential alien contact all contribute to forming vivid memories that feel completely reliable even when they're not. Understanding these psychological and social factors doesn't mean we should dismiss everyone who believes in conspiracy theories as irrational or mentally unstable. The cognitive biases and emotional needs that make such theories appealing are universal human traits that affect all of us to varying degrees. The difference between believers and skeptics often isn't intelligence or education level, but rather exposure to different information sources, social environments, and life experiences. Someone who grows up in a community where distrust of authority is common, who encounters conspiracy theories through trusted friends or family members, and who lacks access to high-quality science education, may find extraordinary claims much more plausible than someone with different background experiences. This realization has important implications for how we approach conspiracy theory believers and try to promote more accurate understanding of scientific issues. Simply presenting facts and evidence isn't usually enough to change deeply held beliefs, especially when those beliefs serve important psychological and social functions. More effective approaches focus on understanding and addressing the underlying needs that conspiracy theories fulfill. This might involve acknowledging legitimate concerns about institutional transparency, providing alternative sources of meaning in community, and demonstrating respect for people's intelligence and autonomy while gently challenging their conclusions. The goal isn't to shame or ridicule people for holding unconventional beliefs, but rather to create environments where evidence-based thinking can flourish alongside healthy skepticism and wonder about the natural world. This requires patience, empathy, and recognition that changing minds is a gradual process that can't be rushed or forced. The Black Knight satellite theory also highlights important questions about how scientific institutions communicate with the public about space-related discoveries and mysteries. The way that space agencies, universities, and research organizations present their findings can either support or undermine public understanding of scientific methods and conclusions. When NASA releases photographs of unusual objects without immediate context or explanation, they create information vacuums that conspiracy theories can rush to fill. When scientists use technical language that's difficult for non-experts to understand, they inadvertently exclude the public from important conversations about space exploration and discovery. Better science communication requires recognizing that the public has legitimate interests in space-related phenomena and deserves clear, accessible explanations of what we know and don't know about the universe. This means being honest about uncertainty while also explaining why scientific methods are more reliable than intuition or speculation for understanding complex phenomena. It also means acknowledging that genuine mysteries exist and that science is an ongoing process of discovery rather than a completed body of knowledge. The long-delayed echoes detected by Jürgen Haas nearly a century ago remain unexplained by modern science. This doesn't mean they require alien explanations, but it does mean that scientists should continue investigating rather than dismissing the phenomenon as unimportant. The persistence of the Black Knight satellite theory in an age of advancing space technology and improving scientific understanding suggests that we need better strategies for preserving public wonder about the cosmos while promoting critical thinking about extraordinary claims. This is one of the great challenges facing science education in the digital age. The real universe revealed by astronomy and space exploration is genuinely more amazing than any conspiracy theory. We live in a cosmos filled with phenomena that would have seemed like magic to previous generations. Black holes warp space and time so severely that they stop clocks and stretch light into infinity. Neutron stars spin hundreds of times per second while generating magnetic fields trillions of times stronger than Earth's. Dark matter makes up most of the universe's mass, but interacts so weakly with ordinary matter that we can barely detect it. We've discovered planets made of diamond, storms larger than Earth that have raged for centuries, and galaxies so distant that we see them as they were when the universe was young. We've detected gravitational waves from colliding black holes, observed the formation of new stars in distant nebulae, and found evidence of liquid water on multiple worlds in our own solar system. These genuine discoveries offer the same sense of cosmic wonder and significance that conspiracy theories promise, but they're grounded in evidence and observation rather than speculation and wishful thinking. They represent humanity's actual expansion into the cosmos rather than imagined visitation from elsewhere. The challenge for educators and communicators is presenting these genuine wonders in ways that capture public imagination while maintaining scientific rigor. This means being honest about what we know and don't know, explaining how scientific knowledge is built through careful observation and testing, and demonstrating why evidence-based approaches are more reliable than assumption and speculation. It also means recognizing that the search for extraterrestrial life is a legitimate scientific endeavor that deserves serious investigation using rigorous methods. Projects like SETI, the search for exoplanets, and missions to potentially habitable worlds represent humanity's systematic attempt to answer one of our most profound questions. Are we alone in the universe? These investigations may eventually provide the definitive evidence for extraterrestrial life that has eluded us for so long. But when that evidence emerges, it will come through careful observation and analysis rather than wishful interpretation of ambiguous phenomena. It will be based on reproducible measurements rather than personal testimonies or grainy photographs. The way we prepare for and respond to such discoveries will depend partly on how well we've learned to distinguish between genuine scientific mysteries and manufactured controversies. The Black Knight satellite story provides a valuable case study in this distinction, showing how extraordinary claims can persist and evolve despite the absence of credible supporting evidence. As we continue pushing the boundaries of space exploration and searching for signs of life beyond Earth, we'll undoubtedly encounter new phenomena that challenge our understanding and resist easy explanation. Some of these discoveries may indeed revolutionize our view of the universe and our place within it. But distinguishing genuine breakthroughs from false alarms will require the same careful, methodical approach that has guided scientific progress for centuries. It will require patience, skepticism, and intellectual honesty. It will require being willing to admit when we're wrong, to revise our theories when new evidence emerges, and to distinguish between what we want to believe and what the evidence actually supports. The Black Knight satellite may be a myth, but the questions it represents about alien intelligence, space exploration, and the nature of mystery remain as compelling today as they were when Tesla first detected those puzzling radio signals over a century ago. The difference is that we now have the tools and knowledge to investigate these questions systematically, following the evidence wherever it leads, rather than jumping to conclusions based on incomplete information and wishful thinking. In many ways, the Black Knight satellite theory serves as a mirror, reflecting our own hopes, fears, and assumptions about the universe back at us. It shows us what we want to believe about alien life, government secrecy, and humanity's cosmic significance. But it also shows us the importance of maintaining critical thinking skills in an age of information overload, where compelling narratives can spread faster than the facts needed to evaluate them. The story reminds us that wonder and skepticism aren't opposites, but rather complementary aspects of the scientific mindset. We can maintain our sense of awe about the cosmos, while still demanding evidence for extraordinary claims. We can acknowledge the genuine mysteries that surround us, while resisting the temptation to fill gaps in our knowledge with comfortable fantasies. As we stand on the threshold of potentially answering some of humanity's oldest questions about life in the universe, the lessons learned from the Black Knight satellite legend become more important than ever. The way we handle mystery, evaluate evidence, and communicate scientific findings will determine whether future discoveries lead to genuine understanding or simply spawn new generations of unfounded speculation. The Black Knight satellite may not exist, but the human drive to explore, question, and seek meaning in the vast darkness of space is very real. That drive has already taken us further than our ancestors could have imagined, and it will continue to push the boundaries of knowledge and exploration for generations to come. The question isn't whether we'll continue discovering and exploring. The question is whether we'll use our natural curiosity to pursue genuine understanding or lose ourselves in elaborate fantasies about ancient watchers in the sky. The choice, like the mystery itself, remains ours to make as we continue our journey into the cosmos, armed with both wonder and wisdom, both dreams and data. And perhaps that's the real lesson of the Black Knight satellite story. Not that we should stop questioning or seeking, but that we should question more carefully and seek more systematically. Not that mysteries don't exist, but that solving them requires more than wishful thinking and pattern seeking. Not that the universe isn't amazing enough to inspire awe and wonder, but that its genuine mysteries are far more profound than any conspiracy theory could ever capture. The search continues, both for answers about potential alien life and for better ways to distinguish between genuine discovery and compelling fiction. In that search, the Black Knight satellite serves not as evidence of ancient extraterrestrial surveillance, but as a reminder of how easily we can fool ourselves when we want to believe something badly enough. The real Black Knight isn't an alien probe orbiting Earth. It's the challenge of maintaining intellectual honesty and critical thinking in a universe full of genuine wonders that don't always match our expectations or desires. Meeting that challenge may be harder than detecting any alien signal, but it's essential if we hope to understand our true place in the cosmic community we're still seeking to join. The truth, as it often does, lies somewhere between the believers and the skeptics. When we strip away the decades of speculation and wishful thinking, when we examine each piece of evidence with the cold light of scientific scrutiny, the Black Knight satellite reveals itself not as an ancient alien probe, but as something far more interesting and perhaps more important. It's a mirror that reflects our deepest desires about the universe and our place within it. It shows us how desperately we want to matter, how much we need to believe that someone, somewhere, is watching over us in the cosmic dark. It demonstrates the remarkable power of the human mind to weave disparate threads into compelling narratives, even when those threads were never meant to be connected. Tesla's mysterious radio signals weren't messages from an ancient probe. They were likely natural phenomena that our primitive understanding of radio astronomy couldn't explain in 1899. The long-delayed echoes that puzzled researchers for decades remain unexplained, but they don't require alien technology. Sometimes the universe simply presents us with mysteries that our current knowledge can't solve. and that's okay. Mystery is what drives discovery forward. The objects detected during the Cold War turned out to be exactly what paranoid military minds feared they might be: spy satellites and space debris from humanity's own tentative steps into the void. The dramatic photographs from 1998 showed us how even the most mundane objects can appear extraordinary under the alien conditions of space, where thermal blankets twist into shapes that our earthbound minds struggle to recognize. But perhaps most importantly, the Black Knight satellite story shows us something profound about ourselves. We are a species that cannot resist the pull of mystery, the lure of the unknown. We look up at the stars and we dream of contact, of purpose, of cosmic significance that extends beyond our small blue world. This desire isn't foolish or naive. It's fundamentally human. It's what drove Tesla to build his impossible machines in the Colorado wilderness. It's what compelled Howells to spend long nights listening to radio echoes from space. It's what motivates today's scientists to point radio telescopes at distant stars, hoping to catch a whisper of intelligence in the cosmic static. The Black Knight satellite may be a myth, but the questions it represents are eternal. Are we alone? Have we been watched? Do we matter to anyone besides ourselves? These questions have haunted humanity since we first looked up at the night sky and wondered what might be looking back. The difference between science and conspiracy theory isn't that one asks these questions and the other doesn't. The difference lies in how we seek the answers. Science demands patience, rigor, and the willingness to accept uncomfortable truths. Conspiracy theories offer immediate satisfaction, dramatic narratives, and the comfort of certainty in an uncertain universe. Real discovery requires us to follow the evidence wherever it leads, even when it leads to mundane explanations for extraordinary phenomena. It means accepting that thermal blankets can look like alien artifacts, that natural radio signals can seem like alien communication, and that our pattern-seeking minds can create connections where none actually exist. But here's what's remarkable about this process. When we strip away the fantasy and examine the reality beneath, we often find something even more amazing than what we imagined. The universe revealed by genuine scientific investigation is stranger and more wonderful than any conspiracy theory. We live in a cosmos where space and time can be warped by gravity, where matter can be converted directly into energy, where quantum particles can exist in multiple states simultaneously until observed. We've discovered worlds made of diamond, detected the echoes of the Big Bang itself, and found evidence that most of the universe consists of mysterious dark matter and dark energy that we can barely comprehend. These genuine discoveries offer the same sense of cosmic wonder that the Black Knight satellite promised, but they're grounded in evidence rather than speculation. They represent humanity's actual expansion into the universe rather than imagined visitation from elsewhere. They show us that reality is often more extraordinary than fiction, but only if we're brave enough to look honestly at what the evidence reveals. The search for extraterrestrial intelligence continues through legitimate scientific channels. Radio telescopes scan the sky for artificial signals, while space telescopes analyze the atmospheres of distant planets for signs of life. Robotic probes explore the subsurface oceans of icy moons, searching for environments where biology might flourish. These investigations may eventually answer the question that drives so much of our speculation about mysterious satellites and ancient visitors. But when that answer comes, it will arrive through careful observation and rigorous analysis, not through the reinterpretation of century-old radio signals or the misidentification of space debris. Until then, we wait and we search and we wonder. We point our instruments at the stars and listen for the cosmic equivalent of Tesla's mysterious signals, knowing that when we finally hear them, will have the tools and knowledge to distinguish between natural phenomena and genuine alien communication. The Black Knight satellite story will likely persist, regardless of what discoveries await us among the stars. It serves too many psychological needs and fits too well with our digital information environment to simply fade away. New generations of believers will continue to find the theory online, share it through social media, and add their own interpretations to the growing mythology. But understanding why the theory persists and what it tells us about human nature and modern information systems may be just as important as any alien signal we might someday detect. Because in the end, the most interesting mystery isn't whether there are ancient alien probes orbiting Earth. The real mystery is how we process mystery itself in an age of infinite information and finite wisdom. How we distinguish between genuine scientific puzzles and manufactured controversies. How we maintain our sense of wonder about the cosmos while developing better tools for separating fact from fiction. The Black Knight satellite may not exist, but the human capacity for curiosity, wonder, and exploration that created its legend is very real. That capacity has taken us from Tesla's primitive radio experiments to sophisticated space telescopes capable of detecting Earth-like worlds around distant stars. It's what will ultimately answer the question of whether we're alone in the universe, regardless of what that answer turns out to be. As we continue our journey into the cosmos, armed with both dreams and data, both wonder and wisdom, the story of the Black Knight satellite serves as both a cautionary tale and an inspiration. It reminds us to question carefully, to seek systematically, and to never stop marveling at the genuine mysteries that surround us. The search continues, not for ancient alien watchers in the sky, but for truth itself in all its complex, nuanced, and often surprising forms. And in that search, we might just discover something more valuable than any alien artifact, a deeper understanding of ourselves and our place in the vast, mysterious, and ultimately knowable universe that we call home. The truth is, we may never know for certain whether Tesla detected signals from an ancient alien probe, whether those delayed radio echoes truly came from unknown objects in space, or whether that twisted piece of thermal blanket photographed in 1998 was something far more extraordinary than NASA claimed. But perhaps that's exactly as it should be. Perhaps the real value of the Black Knight satellite story isn't in its truth or falsehood, but in what it teaches us about the nature of mystery itself and our relationship with the unknown. We live in an age where information travels at the speed of light, where satellite images can circle the globe in seconds, where anyone with a smartphone can access more data than entire libraries once contained. Yet somehow, in this hyper-connected world, mystery has not disappeared. If anything, it has multiplied, fragmented into countless digital pieces that can be assembled into any narrative we choose to believe. The Black Knight satellite legend shows us how modern myths are born and how they evolve in the digital ecosystem. It demonstrates the power of human pattern recognition, the allure of cosmic significance, and the deep psychological needs that conspiracy theories fulfill. Most importantly, it reminds us that in our search for truth about the universe, we must remain vigilant about our own capacity for self-deception. As we stand on the threshold of potentially answering humanity's oldest question about our place in the cosmos, the lessons learned from this century-long mystery become more crucial than ever. When we finally do detect evidence of extraterrestrial intelligence, when we make contact with civilizations among the stars, we'll need to distinguish genuine discovery from wishful thinking, authentic signals from terrestrial interference, and revolutionary science from compelling fiction. The real Black Knight satellite isn't an ancient alien probe silently watching from orbit. It's the challenge of maintaining intellectual honesty in a universe full of genuine wonders that don't always match our expectations. It's the responsibility we all share to question carefully, seek systematically, and never stop marveling at the authentic mysteries that surround us. So the next time you look up at the night sky and wonder what might be looking back, remember the story of the Black Knight satellite. Remember that the universe is vast and strange and full of phenomena we don't yet understand. Remember that extraordinary claims require extraordinary evidence, but also remember that the ordinary explanations, when examined closely, often turn out to be extraordinary in their own right. The search for truth continues, both in the depths of space and in the depths of human nature. And in that search, we might just discover that the most profound mysteries aren't about ancient alien watchers or government conspiracies, but about ourselves and our endless capacity to dream, to wonder, and to seek meaning in the cosmic dark. The Black Knight satellite may be a myth, but the questions it represents, the wonder it inspires, and the caution it teaches us are very real. And in the end, perhaps that's the most important discovery of all.